Hey, what's up guys? Back again with another video in the Java I/O series. This episode we're going to be going over the input stream. So last episode and the episode before that we covered the basics of Java I/O and then output streams the next episode. So we've got a good understanding at least of how things work so far on the basic level. So this will be the last introduction video, and the next episode we're going to start actually working with streams and stuff like that, okay? So it's going to be exciting. Anyway, so we're going to be going over, like I said, input stream this episode. So this is going to be a stream that allows you to take input from some source, okay? And this is the top level class. It's abstract, meaning it cannot be, there's no concrete object that can be made from this because it's not concrete, it's abstract, right? So any subclass of input stream is going to override the method of read, and it can override the other ones too, but it's going to override this one at least because this one is abstract, so it has to be overridden, okay? Same thing, pretty similar to output stream, but it has a lot more methods as you can see here. Output stream had 5, but this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different methods, so yeah, it's pretty detailed. So we're going to cover most of those, then we're going to get some real world experience with those. And then next episode, we're going to get more experience with those, okay? So anyway, yeah, that's about it. Okay, so the main thing that we're going to go over first is going to be the read method, because that's how you read one single byte from the input stream, okay? So for example, if we have a file, we can connect an input stream to that file and then read 1 byte of data from it at a time, okay, by using the read method. So let me show you how to do that. So first we need an input stream to actually access, right? So last episode we used the system.out output stream, which is part of the print stream class. But this episode, to gather input, we're going to use system.in, which is very similar except that it's gathering input, right? So since we know this is an input stream now, we can call upon the read method to read any bytes from it, okay? And we know we can call upon any of these 12 methods because it's an input stream. I think I just said the same thing twice, but you get the point, right? So there's different overridden versions of this read method, but this is the most simple version with no parameters. It's going to return an integer, which is going to be 0 through 255, a unsigned byte, okay? So we can do that, and it says unhandled exception java.io exception. So we need to handle this, right? So we're going to do that. All you got to do is open up a try thing here, and we're going to catch this IO exception ex, and then output if that ever happens, okay? So at this single line of code, we're reading 1 byte of data from the input stream, which is going to be the console, right? So we need to store that data into a variable so we can keep track of it and then output it or do whatever we want to with it at a later date, obviously, right? Because this is returning an integer, of course, so let's put it into an integer. So let's call this integer data. So int data is equal to system.in.read, okay? Pretty cool. So now that we have this data, it hopefully worked correctly, so let's output the data into the console. So we're going to do system.out.write and then data, okay? And this is what we went over last episode. So let's run this and see what happens. Alright, so we get a blank console here, but it's not actually blank because if you click on it, you can actually type stuff now. See, just like that. So it's asking for input from the console because we're using the system.in. So whenever we use that, it's going to ask for input so we can actually input stuff, right? So that's pretty cool. So we can use that for testing purposes like we're doing now. So we're going to say something random like Cody is the best human, okay? And so let's press enter and see what happens. So I pressed enter and then nothing happened, which is strange because we're getting a single byte of input and we're storing it within this integer data variable here, right? And then after that, we're outputting it to the console. But we're using the write method, meaning that's going to be placed into a buffer. So we need to flush it once we're done with that. I forgot to do that, so we're going to do system.out.flush. Alright, so now that should work if we did it correctly. Okay, now it's asking for input, KODY, and now it says K into the console because we're asking for only 1 byte of input, which is equal to 1 character. Pretty cool. So you see the point, really simple. We're just grabbing 1 character from the console after we press enter, so it can get the input from the input stream and then put it into this variable here. Really simple. Alright, so let's get a little more advanced. So let's get multiple bytes of input with a for loop or something like that, right? So let's store that within an array. So int array data is equal to new data, and we have to provide a size for this array. So I'm going to say it's going to gather 10 characters of input, okay, or 10 bytes in this case. Or I put date. Oops, there we go. So data. So yeah, it should store 10 bytes of data if we did this correctly. So we have a little problem here. It says cannot resolve simple data. Oh yeah, it needs to be int. There we go. Sorry about that. A little brain fart. And so now that we're doing that, we need to gather the input, of course. So we're going to make a for loop here. So for int I is equal to 0, as long as I is less than data dot length I++. So it should cycle 10 times, and each of those 10 times is going to take 1 byte of data from the input and then put it into this array here. And then once it's done, it should flush everything to the console so we can see that it worked correctly, okay? That's the plan at least. So we need to do data I is equal to system.in.read. So we're going to grab a single byte of input and then place it into the variable for the index that we're currently on in the for loop, all right? So after that, let's just, for testing purposes, let's just say sout input collected, okay? So we know that it worked correctly. And then after that, let's output everything to the console, okay? So let's get rid of this. We don't need this right now. So for int I is equal to 0, I is less than data.length. So we're just doing the same thing, except this time we're going to be outputting the data that we just collected. So system.out.write data, and then I for the index. And that should do everything. And then after that, we're going to flush it so we know that it worked correctly. Okay, so let's run this and see what happens. Alright, so it's asking for input here, as you can see, because we can click on it and type stuff in. So we're going to say cool mic 35 is a mega noob. Okay, and then after that it says input collected, and then it says cool mic 35. But it doesn't say anything after that. Why is that? That's because we're only asking for 10 bytes of data to be stored in this array here, okay? So we're only calling upon the read method 10 times. So if we count this here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's exactly 10 bytes of data, or 10 characters, so that's why we only get cool mic 35. So let's change this to 20 and see what happens. It should be much larger, the data that we collected. So it's building now, and now it says, oh yeah, we need to type something in. So booty for life or something like that. And nothing happens. Oh yeah, so the reason nothing happens, it doesn't output anything, is because it's asking for 20 bytes of data from the input, right? It's going to use the read method 20 times. And we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes of data here. So we need about 6 more bytes or 6 more characters, and then it should go to the next line. So it's going to continue waiting for input before it actually moves on, because this for loop is still operating, right? It has to reach the max of 20. So yeah, let's put some more stuff in here, like poop is cool too, all right? And let's see what happens. And then it says booty for life, space or enter, and then poop, okay? So let's count the characters just to make sure it worked correctly. It should store 20, right? So 1, 2, 3, 4, 5, space, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And the reason we're stuck on 18 rather than storing 20 is because we have a space here, and then after the space there's an enter. Because remember, in the ASCII table there's actually a character for enter, so those enter counts. So when you press enter before, that counted as a character. So we actually have 20 here, including the space and the enter after this, okay? So hopefully that makes sense for you. But yeah, we're simply grabbing 20 bytes of input from the console using the read method and storing it into this integer array, and then we're outputting it back to the console and flushing it so we can see the result of our operations, okay? So that's how that works, very simple. And I realize I say the word okay very much. I have a problem with that, but hopefully it's not too annoying, okay? Alright, so the next thing I want to show you is -1, okay? So what does -1 mean? So -1 means end of input. So whenever you're gathering input from a file or any input stream, if it ever returns -1, that means that it reaches the end of the input. So there's nothing more after that, okay? So let's test it out. So I can't really test it with the system.in input stream, but I can test it out with a file input stream. We're going to be going over file input streams next episode, but that's not too complicated, okay? So I'm going to code this out real quick, and I'll explain it when I'm done, okay? So we're going to make an input stream here. So input stream input is equal to new file input stream. And we need a file here to access, so we're going to make a new file. We're going to call this booty.txt. That already exists here. I already made it, okay? And then inside of it, it says thy booty so holy. All right. So now we're going to do booty.txt. Okay, so what are we doing here on this first line of code? We're creating a file input stream, which is a subclass of input stream, which is connected to the file booty.txt, okay? So now that we have that input stream established, we can now read the bytes of data from the input stream. So what we're going to do is do a while loop here that runs forever until it reaches -1. Because -1, like I said, it means it's the end of the input. So if we reach the end of the file here, so it should be able to read this line by line, right? And then once it reaches the end of the line here, it should return -1. Okay, so then that's when it's going to break out of the loop and then flush everything for us. Okay, so that's just let's try doing that. All right, so we're going to do int data is equal to input dot read. So it's going to read a single byte of code, and then if data is equal to -1, then what we want to do is do system.out.println end of stream, because that's exactly what it means pretty much. Yep, and then now we want to break it, meaning it's going to get out of the loop here, the while loop, and then move on to the next line of code. All right, and then else if it's not -1, we want to system.out.write the actual byte to the console. So we're going to do that, and then system.out.flush. Okay, so it should print everything to the console if it's not -1, but once it reaches -1, it should say end of stream, and then it should be done here. But we have an error here. It says IO exception, so we just need to handle this real quick. So catch IO exception ex s out ex. Okay, let's get rid of this. We don't need this right now. We're done with that, and everything should work now from this point on. So let's test it out. So what this is going to do, just to recap, is it's going to make a file input stream here, and it should read line by line by using the read method each character from this file here. Okay, so let's see what happens. So let's run this here, and so it says thy booty so holy, end of stream. Okay, that's exactly what we expected, because it's reading it byte by byte, meaning it's going to read T, H, Y, and then once it reaches the end of here, it's going to return -1, therefore, meaning it needs to say this and then break. Okay, very simple. That's exactly how -1 works. If it ever reaches the end of an input stream, meaning there's no other data to be collected or inputted, I guess you could say, then it's going to say -1. Okay, hopefully that makes sense for you. All right, so the next thing I want to show you is how to gather chunks of data. Okay, so chunks of data. So far we've been grabbing data by calling upon the read method on an input stream, which is very good for reading, simple amounts of data. But what if you need like a lot of data? I mean, you could make a for loop like we've been doing like a second ago, but let's say you need like 1,000 bytes of data, right? You can make a for loop that runs 1,000 times, but the more effective way to do is to call upon the other read method so that we can return a byte array so that we can store everything in one line of code without having to loop over and over and over. So let's try doing that. Let's see how we can do that, all right? So we're gonna make a byte array, like I said. So instead of storing everything in an integer array or an integer, we're gonna store it in a byte array. So input is equal to new bytes, and we want this byte array to be 20 characters long, okay? So we can do this really simply, actually. So before we did system.in.read, and we read a single byte of input. As you can see on the right side, it says int. But if we call upon these read methods, we can use the parameters here and provide a byte array for it to be stored inside of. So if you do input, all right, so the way this is going to work is now that you provided a byte array as a parameter, it's going to recognize that you did that, and then it's going to grab 20 bytes of input from the input stream and then put it into that byte array for you, because it knows that you have a byte array of 20 bytes long. So it's going to automatically take 20 bytes and then put it into a byte array. Okay, so this is just a simpler way of doing it rather than doing like for loop like 20 times and then doing int or system.in.read over and over like 20 times. Okay, so it's going to do it all in one line of code really simply for us. So once we grab that input, let's go ahead and output it just for testing purposes. So int I is equal to 0, I is less than input.length, I plus plus, and we're going to do system.out.write, and then we'll do input I, and then after that we're going to do system.out.flush. Alright, and then we're going to catch the exceptions, IO exception, ex, just like that. And yeah, there we go. So that's a lot of code, but what this is going to do, just again to recap, is going to take this byte array and then fill it up with 20 bytes of input from the input stream, okay? Really simple. So let's try running this and see if it works. So it's running now, and it's asking for input here because we just call upon the system.in thing here. So let's do I am really hungry. Alright, so now it says I'm really hungry D because it ran out of characters. So that should be 20 characters. Let's test it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. So I was able to grab 20 bytes and then put it into the input stream. So really easy. So let me explain a little bit of why you want to use this instead of using just a for loop or a loop or something like that to gather input and then put it into a byte array. And the reason is because it's actually faster for some of the subclasses of InputStream. They're optimized basically to grab input faster than like a normal read method would, right? Because what it's doing here is it's grabbing the input from the input stream and then putting it automatically into the byte array, and that's somehow faster than calling upon the read method 20 times, okay? So it's just basically faster for your system to call upon this rather than calling upon read method over and over and over. And there's actually one more third read method that you can use, the byte array, and then 2 other parameters after it. So this is the offset, meaning where you want to start storing data within the byte array. So let's say we have a byte array of 50 bytes. If we want to start at 25, for example, we could do that. And then the length, the third parameter, is going to say how long you want to go for. So 25 through 50. So it's only going to store bytes in the last 25 characters out of the 50 total, like that, okay? So hopefully that makes sense. So you have 50 total, and then it starts at 25 and then goes up to 50, but the first 25 won't be filled up, or the first 24, I guess you could say. But if you want to practice with that, you can. Alright, so the next thing I want to show you is one more method that we can use. Of course, there's 12 total methods that we can use, but this is another important one that you may come across. We're going to be using a file input stream for this because it's not really doable with the system.in input stream, so we're going to do that. So anyway, we'll do try, and then we're going to make a input stream. We're going to call this input is equal to new file input stream booty.txt. And let's say we want to grab everything from this random text file right here, right? So we can make a byte array again to store that data. So we're going to do byte array d is equal to new byte. And we could like count this if we want to by hand. So we can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we can count this file by hand, each character inside of it, and we can put 17 just like that. But that's not really smart. Like, what if you have a huge file? You can't just count every character. That's not really that realistic, right? So something kind of cool that you can do is do input dot, and then there's an available method, which is going to return the estimate of the number of bytes that can be read or skipped over from this input stream. So it's going to automatically get the amount of input that can be gathered from this input stream and then return it for you. So we can basically use this method beforehand so that we know how much data we're going to be storing, so we don't have to count it by hand or something crazy like that, right? So we can do input.read, and then we can just pass in the byte array of d, and then we just need to catch everything, of course. So IO exception, sout exception, okay? And just so we can test and see if this works correctly, we're going to also output the length of the array after we're done storing the data inside of it. So we're going to do, let's do array size is equal to, or is d.length. This is going to get the size of the array and then output it to you. And then now let's print out the content of the array so we can make sure it's stored everything correctly. So I is d.length, I++, sout changes to right, and then we'll do d, and then the index for that. And then finally, system.out.flush, okay? So if this works correctly, what it should do is establish an input stream or a file input stream to the file of booty.txt, and then it's going to check the size of that input stream, basically getting the amount of characters within the file, and it's going to return the amount of bytes in that input stream, and we can use that amount to make a new byte array with that size, so we know how to, or we know how many bytes to store beforehand. And then after that, we're actually going to grab the byte data from the input stream and then store it within that byte array that we just created. And then after that, we're going to say the size of the byte array just to confirm that the input or the available method worked. And then after that, we're finally just going to print everything out to see if it works correctly, okay? So let's run this and see what happens. Perfect, so it says array size is equal to 17, which is exactly what we counted before. And then it says thy booty so holy, so it stored everything correctly also, okay? So let's say we change this to something like add some stuff. Let's see what happens then. Does the size change? It should change because it's automatically going to recognize how many bytes are inside of it. It does. It says array size is equal to 71, so that should be equal to 71, hopefully, if everything was counted correctly. So yeah, that's just a simple method that can help you out whenever you're working with input streams. And the last thing I want to show you is something we did last episode. I showed you how to close an output stream, but this episode I'm going to show you how to close an input stream. Very similar. It's pretty much the same thing. And we're going to do that by adding a finally block of code here. So finally, and we're going to do input.close. But we can't call upon the input variable here or the object here because it's within the scope of this try block of code. So what we can do here is move it outside just like that and set it to null. So it's not initialized here, but once this line of code comes to fruition, I think that's the right word, it's going to now initialize it to a file input stream, and then everything works correctly. It should run out of this, of course, and then once it's done, we should be able to do input.close, which is finally just going to close the stream for us. But we have a problem here. It says java.io exception. So this actually does not handle anything within the finally block here. So we need to make another try and catch block inside of it, which is kind of annoying, but oh well. So IO exception, EX, S out, EX, just like that. So now we're closing this, and actually we can make a further modification to this by doing if input is not equal to null. So if it has been initialized, we want to close it because it's been initialized, right? That means a stream was successfully opened, but if it's not equal to null, nothing needs to happen. It doesn't need to be closed because nothing was ever initialized. No stream was actually opened in the first place, okay? So hopefully that makes sense. That's how you close a simple input stream. So let's see if it works now. Let's run this. And yeah, everything works the same. So yeah, that's it. That's how you gather input from an input stream. There's more methods, of course, that you know are inside of the InputStream class, but we're going to get plenty of experience with those in the future. So don't worry about that, but at least now you have a fundamental understanding of how InputStream works. So now that you can, apply that knowledge to any subclass of InputStream, because they pretty much all work the same, because it's inheriting all the same methods from InputStream itself. All right. So hopefully you're excited for next episode. We're going to actually get started with a input stream, a file input stream, which is something we explored a little bit this episode, but we're going to explore it more in detail next episode. So yeah, stay tuned for that. And if you have any questions about what I showed you this episode, you can ask in the comment section below, or you can join our Discord server. We have a Discord server with about 500 people. So you can, if you need any help at all, I'm here, and then also they're there to help you out and stuff like that, okay? And you can leave suggestions in the Discord server as well if you need to. Also, all the code for today's episode is going to be in the description below, along with the Java docs for the InputStream class, so you can check it out yourself. Alright, so one thing I want to talk about before we go is how to support this channel if you want to. What you can do is go below this video and click the join button, and then you can join this channel as a member for $1, $5, or $10 a month, and you can cancel anytime, and that money goes to support this channel if you want to donate, okay? So yeah, if you want to donate, that's up to you, but if you don't want to, thanks for the support anyway. Thanks for watching. So if you like this video, leave a like. If you need to see more, subscribe, and peace.